A second hazard, pressure changes due to blast, must also be considered. The danger zone for blast should extend no further than the minimum observation distances for thermal radiation exposure. However, if the released vapor cloud is not ignited immediately, a delayed ignition could cause a violent explosion, and the blast from this is unpredictable and could be far-reaching. The furthest reaching danger by far is flying projectiles. Even at the minimum observation distance to avoid excessive radiation, you can still be exposed to this hazard.
11 tests of induced BLEVEs of 400-liter tanks scattered projectiles over a wide area. Note the location of primary fragments, including the tank ends and other large pieces. Secondary fragments, such as piping, attachments, and any other objects near the tank, are also a danger. Note that some large projectiles fell far beyond the suggested 90-meter minimum observation zone for a 400-liter tank. One tank end went 230 meters, 13 times the fireball radius. Records show that in one severe case for a similar-sized tank, a projectile rocketed 22 times the fireball radius, about 400 meters. The best point for observation is beyond the minimum distance to avoid excessive radiation. Face onto the side of the tank and with the wind at your back. Even here you can see that some fragments have fallen beyond the observation point.
To sum up, even for a 400-liter tank, the minimum observation distance for firefighters in protective gear is the minimum distance of 90 meters. This is a suggested minimum distance to avoid extreme danger from the blast and thermal radiation. However, remember, at this distance, you can still be hit by projectiles.
Again, for the 4,000-liter tank, the minimum observation distance becomes 150 meters. And for a 40,000-liter tank, it more than doubles again to 320 meters, with the best observation point being broadside to the tank and upwind. For public protection, consider evacuation distances of about 22 times the fireball radius. 400 meters for a 400-liter tank, 800 meters for a 4,000-liter tank, and 1,800 meters for a 40,000-liter tank.
Think about those distances. Even for the 400-liter tank, the minimum observation distance is 90 meters, well beyond the range of your hoses. And even at 90 meters, you could still be hit by a projectile. These distances provide you with some measure of the risks involved, and you should take these into account when you're faced with responding to a fire where liquefied gas is present. Is there any safe way to approach a fire-impinged tank? Definitely not. As we've said, the best position to observe a damaged or fire-impinged tank is upwind and face on to the side of the tank in order to reduce the danger from projectiles and avoid any escaping vapor cloud. But always keep your distance.
Observing with the wind at your back can give you a false sense of security, because wind can blow the fire to the other side of the tank, so you may not see it contacting the tank. The tank may burst away from you, but the projectiles can still come in your direction. It's unpredictable.
The fact is, there's no safe way to approach a fire-impinged tank, even in protective gear. If you're looking at a big tank, a tank truck, or a tank car, even a fire truck won't be a big enough shield to protect you.
Is the situation under control if the pressure relief valve is releasing gas? No. Liquefied gas tanks can and do fail even when the PRV is trying to relieve excess pressure. PRVs don't prevent the tank from weakening with heat. In fact, by lowering the liquid level in the tank, they can contribute to the weakening of the steel. PRVs releasing pressure do warn us that something is happening. However, with severe fire exposure, a BLEVE can occur whether the PRV is open, closed, or cycling.
If the PRV closes, does that mean the tank is empty? No. Remember, even with the PRV closed, there's still pressure in the tank. In rare cases, the PRV could be stuck, and the tank pressure could be very high.
If the flame is contacting only the bottom of the tank, where the tank shell temperature is kept lower by liquid, can the tank still BLEVE?
Yes, but it may take longer to happen. With a fire on the tank, the situation is always changing. As the fire heats the liquid, the pressure increases.
The PRV opens to relieve the pressure, and the PRV slowly empties the tank. It is doing its job of relieving pressure, but it is also lowering the liquid level in the tank. This can bring flame over the vapor area and possibly cause the tank to fail. Result, a BLEVE.
Is there a difference if the tank is rolled over on its side? Yes. If the PRV is venting liquid, the tank empties more quickly, so that with a severe fire, it can BLEVE sooner. Also, the escaping liquid immediately vaporizes and will ignite on contact with flame or spread in a cloud. Can a thermally protected tank BLEVE? Yes, but it is generally much less likely to. However, if the fire is severe enough, or if the insulation is damaged, the tank wall can be exposed to fire, can heat up unevenly, and could BLEVE. The message is simple. With a fire-impinged tank, you keep your distance. A long, long distance. Whether the tank is large or small, upright or on its side, insulated or not. Whether the PRV is open, closed, or cycling. You can't approach close enough to get water on the tank without getting well into the danger zone. But suppose the fire hasn't reached the tank yet. The flames are getting closer and you want to protect it. What do? Think about it. You can keep the tank cool with water if you can approach close enough to get water on it, and if you have enough water.
But if your fire truck is your only water source, you may not have enough water. A truck carrying 4,500 liters will only provide enough water to keep the tank cool for about 2 to a maximum of 20 minutes, depending on the flow of water and the size of the tank.
Water spray can be effective in keeping a tank cool if the water is applied immediately. However, it requires high volumes of water. For a small 400-liter tank, you need 200 liters a minute. The 4,000-liter storage tank requires 700 liters per minute, and a tanker truck demands 2,000 liters a minute.